Now, he's further ahead on this question than I am. I look at some of the code in trenches and I go like, I'd love to use AI more, and I see how it's making us more productive, but it's not yet at the level where I just go like, oh, we have this project, let me just give it to the AI agent, and it's going to go off and do it.
But let's just be honest. You're like a Clint Eastwood type character, cowboy on a horse, seeing cars going around. And you're like, well,
that's part of it, and I think it is important to have that humility. That what you are good at may no longer be what society values. This has happened a million times in history, that you could have been exceptionally good at saddle making, for example. That's something that a lot of people used to care about because everyone rode a horse. And then suddenly riding a horse became this niche hobby that there's still people who care about it, but not nearly as many. That's okay. Now, the other thing of this is I've had the good fortune to have been a programmer for nearly 30 years. That's a great run. I try to look at life in this way, that I've already been blessed with decades of economically viable, highly valuable ways of translating what I like best in the working world to write Ruby code, that was so valuable that I could make millions and millions of dollars doing it. And if that's over tomorrow, I shouldn't look at that with regret. I should look at it with gratitude.
But you're also a highly experienced, brilliant, and opinionated human being. So it's really interesting to get your opinion on the future of the horse, because there's a lot of young people listening to this who love programming or who are excited by the possibility of building stuff with software, with Ruby on Rails, that kind of language. And now the possibility.
But is it a career?
Is it a career? And how, if indeed a single person can build more and more and more with the help of AI, like, how do they learn that skill? Is this a good skill to learn? I mean, that to me is the real mystery here, because I think it's still absolutely true that you have to learn how to program from scratch currently.
Yes.
But how do you balance those two skills? Because I too, as I'm thinking now, there is a scary slipping away of skill that happens in a matter of like really minutes on a particular piece of code. It's just, it's scary. Not the way driving, when you have a car drive for you, it doesn't quite slip away that fast. So that really scares me. So when somebody comes up to me and asks me like, how do I learn to program? I don't know what the advice is, because I think it's not enough to just use Cursor or Copilot to generate code.
It's absolutely not enough. Not if you want to learn. Not if you want to become better at it. If you just become a tap monkey, maybe you're productive in a second, but then you have to realize, well, can anyone just tap? If that's all we're doing is just sitting around all day long tapping, yes, 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 that's not a marketable skill. Now, I always preface this both to myself and when I speak to others about it, is rule number one, nobody fucking knows anything. No one can predict even 6 months ahead. Right now, we're probably at peak AI future hype because we see all the promise, because so much of it is real and so many people have experienced it themselves. This mind-boggling thing that the silicon is thinking in some way that feels eerily reminiscent of humans. I'd actually say the big thing for me wasn't even ChatGPT. It wasn't even Claude. It was DeepSeek. Running DeepSeek locally and seeing the think box where it converses with itself about how to formulate the response. I almost wanted to think, is this a gimmick? Is it doing this as a performance for my benefit, but that's not actually how it thinks? If this is how it actually thinks, okay, I'm a little scared. Yeah. This is incredibly human, how it thinks in this way. Yeah. But where does that go? So, in 95, one of my favorite B movies came out, The Lawnmower Man.
Great movie.
Incredible movie about virtual reality. Yeah. Being an avatar and living in VR. Like, the story was a mess, but the aesthetics, the world it built up was incredible. And I thought, we're 5 years away. I'm going to be living in VR now. I'm just going to be floating around. I'm going to be an avatar. This is where most humans can spend most of their day. That didn't happen. We're 30 years later. VR is still not here. It's here for gaming. It's here for some specialized applications. My oldest loves playing Gorilla Tag. I don't know if you've tried that. That's basically the hottest VR game. Wonderful. That's great. It's really hard to predict the future because we just don't know. And then when you factor in AI and you have even the smartest people go like, I don't think we fully understand how this works.
But then on the flip side, you have Moore's Law that seems to have worked for many, many, many years in decreasing the size of the transistor, for example. Yes. So like, Flash didn't take over the internet But Moore's law worked. So
Yes.
we don't know
And
which one AI
which
is.
one it is. And this is what I find so fascinating too. I forget who did this presentation, but someone in the web community did this great presentation on the history of the airplane. So you go from the Wright brothers flying in, 1903 or something like that. And 40 years later, you have a jet flight. Just an unbelievable amount of progress in 4 decades. Then in 56, I think it was, the hull design for the Boeing 747, essentially precursor, was designed. And basically nothing has happened since. Just minor tweaks and improvements on the flying experience since the 50s. Somehow, if you were to predict where flying was going to go and you were sitting in 42 and you'd remember the Wright brothers flying in 03 and you were seeing that jet engines coming, you're like, we're going to fly to the stars in another 2 decades. We're going to invent super mega hypersonic flights that's going to traverse the earth in 2 hours. And then that didn't happen. It tapped out. This is what's so hard about predicting the future. We can be so excited in the moment because we're drawing a line through early dots on a chart. And it looks like those early dots are just going up and to the right, and sometimes they just flatten out. This is also one of those things where we have so much critical infrastructure, for example, that still runs on COBOL, that about 5 humans around the world really understand truly, deeply, that it's possible for society to lose a competence it still needs because it's chasing the future. COBOL is still with us. This is one of the things I think about with programming. Ruby on Rails is at such a level now that in 50 years from now, it's exceedingly likely that there's still a ton of Ruby on Rails systems running around. Now, very hard to predict what that exact world is going to be like, but yesterday's weather tells us that if there's still COBOL code from the 70s operating Social Security today, and we haven't figured out a clean way to convert that, let alone understand it, we should certainly be humble about predicting the future. I don't think any of the programmers who wrote that COBOL code back in the 70s had any damn idea that in 2025, checks were still being cut of the business logic that they had encoded back then. But that just brings me to the conclusion on the question for what should a young programmer do? You're not going to be able to predict the future. No one's going to be able to predict the future. If you like programming, you should learn programming. Now, is that going to be a career forever? I don't know. But what's going to be a career forever? Who knows? Like a second ago, we thought that it was the blue-collar labor that was going to be extracted first. It was the robots that were going to take over. Then Gen AI comes out, and then all the artists suddenly look like, holy shit, is this going to do all animation now? Is going to do all music now? They get real scared. And now I see the latest Tesla robot going like, oh, maybe we're back now to blue-collar being in trouble, because if it can dance like that, it can probably fix a toilet. So no one knows anything. And you have to then position yourself for the future in such a way that it doesn't matter, that you pick a profession or path where if it turns out that you have to retool and reskill, you're not going to regret the path you took. That's a general life principle for me. How I look at all endeavors I involve myself in is I want to be content with all outcomes. When we start working on a new product at 37 Signals, I set up my mental model for its success. And I go, do you know what? If no one wants this, I will have had another opportunity to write beautiful Ruby code, to explore a greenfield domain, to learn something new, to build a system I want, even if no one else wants it. What a blessing. What a privilege. If a bunch of people want it, that's great. We can pay some salaries, we can keep the business running, and if it's a blow-away success, wonderful. I get to impact a bunch of people.
I think one of the big open questions to me is how far you can get with vibe coding. Whether an approach for a young developer to invest most of their time into vibe coding or into writing code from scratch. So vibe coding meaning, so I'm leaning into the meme a little bit, but vibe coding meaning you generate code, you have this idea of a thing you want to create, you generate the code, and then you fix it with both natural language to the prompts and manually. You learn enough to manually fix it. So that's the learning process, how you fix code that's generated. Or you write code from scratch and have the LLMs kind of tab, add extra code. Like, which part do you lean on? I think to be safe, you should find the beauty and the artistry and the skill in both, right from scratch. So like there should be some percent of your time just writing from scratch and some percent vibe coding.
There should be more of the time writing from scratch. If you are interested in learning how to program, unfortunately, you're not going to get fit by watching fitness videos. You're not going to learn how to play the guitar by watching YouTube guitar videos. You have to actually play yourself. You have to do the sit-ups. programming, understanding, learning almost anything requires you to do. Humans are not built to absorb information in a way that transforms into skills by just watching others from afar. Now, ironically, it seems AI is actually quite good at that, but humans are not. If you want to learn how to become a competent programmer, you have to program. It's really not that difficult to understand. Now, I understand the temptation, and the temptation is there because vibe coding can produce things, perhaps in this moment, especially in a new domain you're not familiar with tools you don't know perfectly well, that's better than what you could do, or that you would take much longer to get at, but you're not going to learn anything. You're going to learn in this superficial way that feels like learning, but is completely empty calories. And secondly, if you can just vibe code it, you're not a programmer. Then anyone could do it, which may be wonderful. That's essentially what happened with the Access database. That's what happened with Excel. It took the capacity of accountants to become software developers because the tools became so accessible to them that they could build a model for how the business was going to do next week. That required a programmer prior to Excel. Now it didn't because they could do it themselves. Vibe coding enables non-programmers to explore their ideas in a way that I find absolutely wonderful. But it doesn't make you a programmer.
I agree with you, but I want to allow for room for both of us to be wrong. For example, there could be vibe coding could actually be a skill that if you train it, and by vibe coding, let's include the step of correction, the iterative correction.
Yes.
It's possible if you get really good at that you're outperforming the people that write from scratch, that you can come up with truly innovative things, especially at this moment in history, while the LLMs are a little bit too dumb to create super novel things in a complete product, but they're starting to creep close to that. So if you're investing time now into becoming a really good vibe coder, maybe this is the right thing to do. As if it's indeed a skill, we kind of meme about vibe coding, just like sitting back and it's in the name. But if you treat it seriously, a competitive vibe coder, and get good at riding the wave of AI, and get good at the skill of editing code versus writing code from scratch, it's possible that you can actually get farther in the long term. Maybe editing is a fundamentally different task than writing from scratch, if you take that seriously as a skill that you develop. To me, that's an open question. I just think I personally, and now you're on another level, but just me, just personally, I'm not as good at editing the code that I didn't write. That's a different. No one is of this generation, but maybe that's a skill. Maybe if you get on the same page as the AI, because there's a consistency to the AI. It's like it really is a pair programmer with a consistent style and structure and so on. Plus, with your own prompting, you can control the kind of code you write. I mean, it could legitimately be a skill. Like,
that's the dream of the prompt engineer. I think it's a complete pipe dream. I don't think editors exist that aren't good at writing. I've written a number of books. I've had a number of professional editors. Not all of them wrote their own great books, but all of them were great writers in some regard. You cannot give someone pointers if you don't know how to do it. It's very difficult for an editor to be able to spot what's wrong with a problem if they couldn't make the solution themselves. Editing, in my opinion, is the reward. The capacity to be a good editor is the reward you get from being a good doer. You have to be a doer first. Now, that's not the same as saying that vibe coding, prompt engineering, won't be able to produce fully formed, amazing systems even shortly. I think that's entirely possible. But then there's no skill left, which maybe is the greatest payoff at all. Wasn't that the whole promise of AI anyway? That it was just all natural language, that even my clumsy way of formulating a question could result in a beautiful, succinct answer? That actually, to me, is a much more appealing vision, that there's going to be these special prompt engineering wizards who know how to tickle the AI just right to produce what they want. The beauty of AI is to think that someone who doesn't know the first thing about how AI actually works is able to formulate their idea and their aspirations for what they want, and the AI can somehow take that messy clump of ideas and produce something that someone wants. That's actually what programming has always been. There's very often been people who didn't know how to program, who wanted programs, who then hired programmers, who gave them messy descriptions of what they wanted, and then when the programmers delivered that back, said, oh no, actually that's not what I meant. I want something else. AI may be able to provide that cycle. If that happens to the fullest extent of it, yeah, there's not going to be as many programmers around, right? But hopefully presumably someone still, at least for the foreseeable future, have to understand whether what the AI is producing actually works or not.
As an interesting case study, maybe a thought experiment, if I wanted to vibe code Basecamp or HEY, and some of the products you've built, like what would be the bottlenecks? Where would I fail along the way?
What I've seen when I've been trying to do this, trying to use vibe coding to build something real, is you actually fail really early. The vibe coding is able to build a veneer at the current present moment of something that looks like it works,
Right.
but it's flawed in all sorts of ways. There are the obvious ways, the meme ways that it's leaking all your API keys, it's storing your password in plain text. I think that's ultimately solvable. Like, it's going to figure that out, or at least it's going to get better at that. But its capacity to get lost in its own labyrinth is very great right now. You let it code something, and then you want to change something, and it becomes a game of whack-a-mole real quick. Peter Levels, who've been doing this wonderful flight simulator, we're talking to that, where at a certain scale, the thing just keeps biting its own tail. You want to fix something, and it breaks 5 other things, which I think is actually uniquely human, because that's how most bad programmers are. At a certain level of complexity with the domain, they can't fix one thing without breaking 3 other things. So in that way, I'm actually, in some ways, almost a positive signal for that the AI is going to figure this out, because it's on an extremely human trajectory right now. The kind of mistakes it's making are the kind of mistakes that junior programmers make all the time.
Yeah. Can we zoom out and look at the vision, the manifesto, the doctrine of Rails? What are some of the things that make a programming language, a framework great, especially for web development? So we talked about happiness.
Yes.
The underlying objective of Ruby. What else?
So you're looking at the 9 points I wrote out in, I think, 2012. And first, before we dive into them, I want to say the reason I wrote it down is that if you want a community to endure, you have to record its values and you have to record its practices. If you don't, eventually you're going to get enough new people come in who have their own ideas of where this thing should go. And if we don't have a guiding light helping us to make decisions, we're going to start flailing. We're going to start actually falling apart. I think this is one of the key reasons that institutions of all kinds start falling apart. We forget why Chesterton's fence is there. We just go like, why is that fence there? Let's yank it out. Oh, it was to keep the wolves out. Now we're all dead. Oops. So I wanted to write these things down. And if we just take them quick one by one, you talked about optimizing for programmer happiness. I put that at number 1 in homage of Matt's. And that's a lot about accepting that there is occasionally a trade-off between writing beautiful code and other things we want out of systems. There can be a runtime trade-off, there can be a performance trade-off, but we're going to do it nonetheless. We're also going to allow ambiguity in a way that many programmers by default are uncomfortable with. I give the example actually here of in the interactive Ruby shell, where you could play with the language or even interact with your domain model, you can quit it in 2 ways, at least that I've found. You can write exit, boom, you're out of the program. You can write quit, boom, you're out of the program. They do the same thing. We just wrote both exit, or the people who built that wrote both exit and quit because they knew humans were likely to pick one or the other. Python is the perfect contrast to this. In the Python interactive protocol, if you write exit, it won't exit. It'll give you a fucking lesson. It'll basically tell you to read the fucking manual. It says use exit parentheses or control D, i.e. end of file to exit. I'm like, one is very human and another is very engineer. And I mean that both of them in the best possible way. Python is pedantic. Python's the value from the start stated is that there should be preferably one and only one way to do a certain thing. Ruby goes the complete opposite. No, we want the full expression that fits different human brains such that it seems like the language is guessing just what they want.
And part of that is also you described the principle of least surprise, which is a difficult thing to engineer into a language. Because you have to kind of, it's a subjective thing.
Which is why you can't do it in one way, which is why I use the example of both exit and quit. Yeah. The principle of least surprise for some people would be like, oh, exit, that's how I get out of the prompt. For other people, it would be quit. Why don't we just do both?
Okay, so what's the convention over configuration? That's a big one.
That's a big one. That's a huge one. And it was born out of a frustration I had in the early days with especially Java frameworks, where when you were setting up a web application framework for Java back in the day, it was not uncommon to literally write hundreds, if not thousands of lines of XML configuration files. Oh, I need this. I want the database to use the foreign keys as post_ID. No. I want it as post capital ID. Oh, no. You have to do it capital PID. There are all these ways where you can configure how foreign relation keys should work in a database, and none of them matter. We just need to pick one, and then that's fine. And if we pick one and we can depend on it, it becomes a convention. And if it's a convention, we don't have to configure it. And if we don't have to configure it, you can get started with what you actually care about much quicker. So convention over configuration is essentially to take that idea that the system should come pre-assembled. I'm not just handing you a bunch of fucking Legos and asking you to build the Millennium Falcon. I'm giving you a finished toy. You can edit, you can change it. It's still built out of Legos. You can still take some pieces off and put in some other pieces, but I'm giving you the final product. And this cuts against the grain of what most programmers love. They love a box of Legos. They love to put everything together from scratch. They love to make all these detailed little decisions that just don't matter at all. And I want to elevate that up such that, hey, I'm not trying to take the decisions away from you. I just want you to focus on decisions that actually matter, that you truly care about. No one cares about whether it's post_ID or post-ID or PID.
Yeah, great defaults.
Yes.
It's just a wonderful thing. You have all these aspirations. They're going to do some kind of custom, most beautiful Legos castle that nobody's ever built from these pieces. But in reality, to be productive in most situations, you just need to build the basic thing. And then on top of that is where your creativity comes.
Absolutely. And I think this is one of those part of the doctrine that a lot of programmers who get to use Ruby on Rails begrudgingly will acknowledge is a nice thing, even if they don't really like it. Like, it's hard to beat the sort of attraction to building with Legos from scratch out of programmers. That's just what we like. This is why we're programmers in the first place, because we'd like to put these little pieces together. But we can direct that instinct towards a more productive end of the stack.
Okay, what are some of the other ones?
The menu is omakase. It actually comes out of the same principle that great defaults really matter. If you look at everything that's wrong with the JavaScript ecosystem right now, for example, it is that no one is in charge of the menu. There are a billion different dishes and you can configure just your tailored specific configuration of it, but no one done the work to make sure it all fits together. So you have all these unique problems in the JavaScript ecosystem. For example, there's probably 25 major ways of just doing the controller layer. And then as many of how to talk to the database. So you get this permutation of n times n times n of no one is using the same thing. And if they are using the same thing, they're only using the same thing for about 5 minutes. So we have no retained wisdom. We build up no durable skills. Rails goes the complete opposite way of saying, do you know what? Rails is not just a web framework. It is a complete attempt at solving the web problem. It's a complete attempt at solving everything you need to build a great web application. And every piece of that puzzle should ideally be in the box, pre-configured, pre-assembled. If you want to change some of those pieces later, that's wonderful. But on day one, you'll get a full menu designed by a chef who really cared about every piece of the ingredient, and you're going to enjoy it. And that's, again, one of those things where many programmers think, like, I know better. And they do in some hyper-local sense of it. Every programmer knows better. This is what Ruby is built on, that every programmer knows better in their specific situation. Maybe they can do something dangerous. Maybe they think they know better, and then they blow their foot off, and then they truly will know better because they've blown their foot off once and won't do it again. But the menu is omakase is that.
So you, in see the value in the monolith.
Yes. The integrated system.
Integrated
system. Someone thought of the whole problem. This is one of the reasons why I've been on a crusade against microservices since the term was coined. Microservices was born out of essentially a good idea. What do you do at Netflix scale when you have thousands of engineers working on millions of lines of code? No one can keep that entire system in their head at one time. You have to break it down. Microservices can be a reasonable way to do that when you're at Netflix scale. When you apply that pattern to a team of 20 programmers working on a code base of 500,000 lines of code, you're an idiot. You just don't need to turn method invocations into network calls. It is the first rule of distributed programming. Do not distribute your programming. It makes everything harder. All the failure conditions you have to consider as a programmer just becomes infinitely harder when there's a network cable involved. So I hate the idea of premature decomposition. And microservices is exactly that. The monolith says, let's try to focus on building a whole system that a single human can actually understand and push that paradigm as far as possible by compressing all the concepts such that more of it will fit into memory of a single operating human. And then we can have a system where I can actually understand all of Basecamp. I can actually understand all of HEY. Both of those systems are just over 100,000 lines of code. I've seen people do this at maybe twice, maybe 3 times that scale, and then it starts breaking down. Once you get north of certainly 500,000 lines of code, no individual human can do it. And that's when you get into maybe some degree of microservices can make sense.
Basecamp and HEY are both 100,000?
100,000 lines of code.
Wow, that's small.
It is. Considering the fact that Basecamp, I think, has something like 420 screens, different ways and configurations.
Do you include the front end in that?
No, that's the Ruby code. Well, it's front end in the sense that some of that Ruby code is beneficial to the front end, but it's not JavaScript, for example. Now, the other thing we might talk about later is we write very little JavaScript, actually, for all of our applications. HEY, which is a Gmail competitor, Gmail ships, I think, 28 megabytes of uncompressed JavaScript. If you compress it, I think it's about 6 megabytes, 28 megabytes. Think about how many lines of code that is. When HEY launched, we shipped 40 kilobytes. It's trying to solve the same problem. You could solve the email client problem with either 28 megabytes of uncompressed JavaScript or with 40 kilobytes if you do things differently.
Yeah.
But that comes to the same problem, essentially. This is why I have fiercely fought splitting front end and back end apart. That, in my opinion, this was one of the great crimes against web development that we are still atoning for, that we separated and divided what was and should be a unified problem-solving mechanism. When you are working both on front end and back end, you understand the whole system. And you're not going to get into these camps that decompose and eventually you end up with shit like GraphQL.
Okay. Let's fly through the rest of the doctrine. No one paradigm.
No one paradigm goes to the fact that Ruby is a fiercely object-oriented programming language at its core, but it's also a functional programming language. This 5 times I told you about, you can essentially do these anonymous function calls, and you can chain them together very much in the spirit of how true functional programming languages work. Ruby has even moved closer towards the functional programming end of the scale by making strings immutable. There are ideas from all different disciplines and all different paradigms of software development that can fit together. Smalltalk, for example, was only object-oriented, and that was just it. Ruby tries to be mainly object-oriented, but borrow a little bit of functional programming, a little bit of imperative programming, be able to do all of that. Rails tries to do the same thing. We're not just going to pick one paradigm and run it through everything. Object orientation is at the center of it, but it's okay to invite all these other disciplines in. It's okay to be inspired. It's okay to remix it. I actually think one of the main benefits of Rails is that it's a remix. I didn't invent all these ideas. I didn't come up with active record. I didn't come up with the MVC way of dividing an application. I took all the great ideas that I had learned and picked up from every different camp, and I put it together. Not because it was going to be just one single overarching theory of everything, but I was going to have a cohesive unit that incorporated the best from everywhere.
Is that idea a bit at tension with the beauty of the monolith system?
I think the monolith can be thought of as quite roomy, quite as a big tent, that the monolith needs actually to borrow a little bit of functional programming for the kinds of problems that discipline excels at solving, and that paradigm excels at solving. If you also want object orientation at its core, I actually think when I've looked at functional programming languages, there's a lot to love. And then I see some of the crazy contortions they have to go through when part of the problem they're solving calls for mutating something. And you go like, holy shit, this is a great paradigm for 90% of the problem, and then you're twisting yourself completely out of shape when you try to solve the last 10.
Ooh, exalt beautiful code is the next one.
We've talked about that at length, and here's a great example that really summarizes the domain-specific language quality of Ruby on Rails, that you can make code actually pleasant to write and read, which is really funny to me because, as we talked about, when I started learning programming, it wasn't even a consideration. I didn't even know that could be part of the premise, that could be part of the solution, that writing code could feel as good as writing a poem.
Class project, application record belongs to account, has many participants, class name person, validates presence of name.
See, you could read it out. You didn't even change anything.
Like a haiku or something.
Right. Isn't that beautiful?
Yeah, it's nice. It's really nice. There's an intuitive nature to it. Okay, so I have specific questions there. I mean, active record, just to take that tangent, that has to be your favorite feature.
It's the crown jewel of Rails. It really is. It is the defining characteristic of how to work with Ruby on Rails.
Yeah.
And it's born in an interesting level of controversy because it actually uses a pattern that had been described by Martin Fowler in the Patterns of Enterprise Application Architecture, one of the greatest books for anyone working on business systems. And if you had not read it, you must pick it up immediately. Patterns of Enterprise Application Architecture. I think it was published in 2001. It is one of the very few programming books that I have read many times over. It's incredible. In it,